Hey guys, I just wanted to go through pages 16 through 19 with you and chat about a couple of useful things. Okay, so first, for practice worksheet 6, remember we covered this last stuff in our last class, so I'm not going to go through it with you again, but I will discuss each one of these as we go. Okay, so first we have A, and we determined that A has four significant figures just based on rule number 5 here. So we don't really know for sure whether or not we have four sig figs because of that trailing 0 there, but we give it the benefit of the doubt unless it's specified otherwise. Okay, so could be significant, could not be significant. The textbook problems are likely to give us four sig figs, particularly in IB physics. They always do this. Okay, so we're just going to go with 4 for A, recognizing that it could be either 3 or 4. We don't know for sure. Okay, for B, we have 3 significant figures because that trailing 0 there is behind a decimal place, and therefore all 3 of those figures are significant. 1, 3, and 0, the trailing 0, are significant. So that 0 is our estimate as well. C is very straightforward. It's 4 significant figures. D, slightly less straightforward, but recall that any zeros in front of our number are not significant. So we have 3 sig figs for D. E gives us 3 significant figures. It's in scientific notation using the calculator notation that I do not particularly like, but in scientific notation generally all figures shown are significant. Okay, F, 3 sig figs. Again, that trailing 0 there has been, we assume that it has been measured, especially since it's after a decimal point. You wouldn't bother showing it if it had not been. For G, again, very straightforward, 3 sig figs. H, a 0 after a decimal place is always significant, so 4 sig figs. For I, again, we have scientific notation. We only show significant figures in scientific notation. Okay. All right, this last bit, not really much to cover here. We're asked to use 5 for our uncertainty, so it's just a matter of determining which figure is our estimate here. F was a little bit tricky. F, we could have 2 significant figures. I think all the rest of this is pretty self-explanatory, but certainly if you disagree, let me know. Actually, 2 tricky points. E, slightly tricky. So some of you had some questions about this. How do we handle it? Well, this is one possible way that you could handle it. So I've included it there. So 9.55 plus or minus 0.05, and that is in parentheses, times 10 to the 3 centimeters. And we have 3 sig figs on our measurement. Okay, finally, this last one is interesting because we could have 2 sig figs, as I've shown here. We could also have 3 sig figs, and that might look like this, to 3 significant figures for our measurement or estimate. Or we could have all 4 significant figures, and that would look like this. Okay, so any one of those are possible based on the rule that we discussed up here in number 5. So there you go. Okay, so Next, let's put this puppy to bed. So writing numbers to specific number of sig figs. So here we're just asked to round off to specific numbers of significant figures, and these are the answers. Remember, when rounding a number, you just look to the following digit. Okay, so here we're looking at 178.874. So we look at this digit, and if this digit is from 0 to 4, then the previous digit does not change. Okay? If the number is from 5 to 9, we round up. Okay, so there's just a really quick summary of rounding. You just look at the following digit, and then if it's 0 to 4, you don't change anything. If it is 5 to 9, you go ahead and round up, not off. There we go. Up. So in the case of three significant figures, we look to the fourth digit here, and we find that it's between 5 and 9, and that means we round up 178 to 179. Okay, similarly to two significant figures, we look at the third possible significant figure. Again, that is between 5 and 9, so we round the preceding number up to an 8, and that gives us 180. Okay, so what do we do with calculations? Well, this can be a little bit tricky when we're looking at addition, and we'll see that in our next problem. But first, we're looking at density here, and density is calculated using the formula D equals mass divided by volume, and my preferred way to remember this is by I heart density, where density is equal to mass divided by volume, or that little heart split in half there. So there you go. Maybe it should be I don't love density. Okay, anyway, so we solved this equation for mass, and we do that by multiplying both sides of the equation by V, and that will give us mass is equal to density times volume. Okay, so from here, we substitute the appropriate values, and we have density is equal to 4.73 grams per centimeter cubed. Our volume is 16 centimeters cubed. We multiply those together. We should also note that we are going to use the least number of significant figures. So in this case, the smallest number of significant figures is 2. Okay, for volume. So that means that our answer is going to have 2 sig figs. Okay, so our calculator says we have 75.68 grams, but we will round it off to 2 significant figures because 6 is between 5 and 9. We will round it up to 76 grams. Also note that I boxed my final answer. This is a very good habit, especially if you have a tendency to be sloppy. Particularly true on exams, guys. Okay, so here we have a practice worksheet. Find the area of a triangle with base 8.75 and a height of 15.3 centimeters. Our calculation is here. We have 3 significant figures. I don't think I really need to explain much here. Again, the only thing I might mention is this number is between 0 and 4, which means that the previous digit doesn't change when we round off. So we're rounding, in this case, our rounding doesn't do anything to that digit. Okay, so find the area of a circle with a radius of 28 centimeters. I plugged those values into my calculator, and I did not show the calculator output, but it was surely not 2,500. I've just rounded it right off because I'm in a hurry, or I was in a hurry. Okay, find the average speed in meters per second of a runner who travels 675 meters in 224.56 seconds. Well, our final answer will have three significant figures because the smallest number of sig figs in our values that we will be calculating is 3. Okay, so we plug this value into our calculator again, and we round off to 3.01 meters per second. Okay, well, I think that is going to do it for this particular video. Let me know if you have any questions or comments, or you think that there is a mistake via the Google chat room. There may well be some. So, have a great day, guys.